In this lecture, we will talk about the differences between the terms blocking and suspending. I'm going to start by explaining what blocking means with the help of the thread example of the last lecture. Let's have a look at it again. The main function calls the function called thread routine 2 times. For each invocation, a new thread is started in which work gets performed. This work is represented by a call to thread.sleep. Before and after the work, we print out the status. After invoking the functions, the main function sleeps for 1000 milliseconds to wait for the threads to complete. Let's illustrate what's going on. Our main function runs on the main thread. At first, the functions called threadRoutine1 and threadRoutine2 are called, and a new thread is started for every function invocation. In each thread, it is printed that the function starts to work. Then, the work is started in form of a thread.sleep call, and afterwards it is printed out that the work in the thread has finished. The main function sleeps for 1000 milliseconds too, in order to wait for the threads to finish. The thread.sleep commands here are classic examples for blocking calls. While the 3 threads are sleeping, they can't work on other tasks. In other words, the thread is doing nothing but waiting until the sleep period is over. This occupies the CPU with unnecessary waiting. It would be much better if it could work on other tasks in the meantime. If we would do a blocking call, like thread.sleep for instance, on the Android main thread, our UI would freeze for the specified amount of time, as it wouldn't be able to work on UI-related tasks like drawing to the screen. Next, we're going to find out what the term suspending means by having another look at our coroutine example. This example is located in the file for coroutineswiththreadinfo.kt. So what's basically happening in this example that we have written in the beginning of this section is that we're starting 2 coroutines in our main function, and each one of the coroutines calls a suspend function, and this suspend function basically does the same thing as in the thread example. It performs some work and prints out the current status and the name of the thread it is running on. The main difference, however, is that it uses the suspend function delay instead of the blocking thread.sleep command. Let's illustrate this example too. The main function again runs on the main thread, and it starts 2 coroutines, and the first coroutine prints out that it starts now its work and then calls delay. As we have seen in the last lecture, the code of our coroutines is executed on the main thread. When delay gets called, the first coroutine gets suspended. This is possible because the call to the suspend function delay is a suspension point. Then the second coroutine prints out that it has started. It also calls delay next and then gets suspended too. When the 300 milliseconds of the second coroutine have passed, it wakes up, starts to run again, and then prints on the main thread that it has finished. The same happens with coroutine number 1. The crucial thing to understand here is that while both coroutines are suspended, the main thread is not blocked and therefore can work on other tasks. That's the big difference to the thread example, in which the main thread was blocked and not able to work on other tasks. Let's write some code to see that my claims of the main thread being able to perform work while the coroutines are suspended are actually true. We start by copying this coroutine example and paste it as 8 suspending coroutines. Let's rename the function to suspending coroutine and also change that the main function calls this exact function. Next, we are going to start another coroutine by using the async coroutine builder once again. In the coroutine builder, we print out that another task is working, and we also add the thread information. We repeat this print statement for 5 times and add a delay of 100 milliseconds between each invocation. Let's execute this code. In the print output, you can see that both coroutines started to work and then got suspended. While they were suspended, the main thread indeed was able to work on other tasks. This is the power of suspending instead of blocking. I said before that it's bad to perform a blocking call like thread.sleep on the Android main thread. However, because of the reasons mentioned before, it is certainly possible to call a suspend function like delay from the Android main thread without freezing the UI. I have to speak a word of caution though. Just by using coroutines and suspend functions doesn't mean that your threads can't ever be blocked. For instance, nobody will prevent you to call thread.sleep in one of your suspend functions, which will lead to blocking the thread. However, there is a convention that a suspend function shouldn't block the calling thread. You will learn more about this convention when we are going to write our first use case with coroutines. We talked a bit about suspending in the first lecture of this section, when we compared ordinary routines with coroutines. There, we said that the special thing about coroutines compared to regular routines was that they can be suspended and continued at a later point. The important thing we learned in this current lecture is that while coroutines are suspended, they don't block any thread. So if we, for instance, start a coroutine on the main thread and the coroutine gets suspended at the suspension point, the main thread is able to execute other operations in the meantime. This is not possible when the thread is blocked. So this was a free video from my online course called Mastering Kotlin Coroutines for Android Development, which contains more than 9 hours of high quality video content and is therefore probably the most extensive and in-depth resource about coroutines on Android. If you are interested, please check out the link in the description.